A3 quadratic functions in Vertex form. Basically what we're going to do today is doing a little investigation on how quadratic functions translate and transform. We're going to look to see what happens here. So what you'll want to do is make sure that you're logged into the Moodle site and that you're going to be using your graphing calculator here. So we'll have that handy for and available. First things first, we're going to look at the first question here. So you'll want to follow along in your packet. Graph y equals x squared, y equals 2x squared, y equals 5x squared, y equals 12x squared on the same axis. Describe what happens to the graphs of y equals x squared when the coefficient of x squared is greater than 1. So we're comparing to y equals x squared. I want you to go ahead, pause the video, and go ahead and put these 4 into your graphing calculator. I have my 4 equations in my graph here. Notice that y is already given, so we just need to fill in the second half of our equation. Notice the colors here. We have red, green, blue, and yellow. Those will be according to each one of the graphs. So we are going to make a comparison into x squared. Notice that our coefficient, our a values, are going up here. So we have 2, 5, and 12. Let's go ahead and graph this to see what happens. You have your graph right here in front of you. What observation do you see? Well, you should have stated that when the coefficient of a is greater than 1, so when it gets further away from 1, this is what happens. The graph becomes narrower when the coefficient in front of x squared is greater than 1. The greater the number, the more narrow it becomes. In graph, or step 2, here's our equation. We're at a graph on the same axis. This time we're going to describe what happens to the coefficient when it's between 0 and 1. So if you look at all these, our coefficient would be between 0 and 1. Again, pause the video and input these 4 into your graph. I have my 4 graphs input in. I'm going to go ahead and graph. And we see what's happened here. Y equals x squared. Well, look what happens when the values of a get closer to 0. The closer it is to 0, the wider the graph gets. So we can go ahead, flip back, and input that into 2. Graph becomes wider when the coefficient in front of x squared is between 0 and 1. The closer to 0, the wider the graph. In 3, we're going to see what happens when the coefficient of x squared is negative. I'm just going to go back. I still have some graphs here before. I'm just going to go ahead and throw a negative sign in front of each one of these, and we're going to see what happens when the coefficient out in front of x squared is negative. And again, you should have already made somewhat of a prediction in your head. We're going to test it right now. And we find out that our graphs curve down now. So when the coefficient is negative, the graph will curve down. And that's what we have stated, graph curves down. Example 4 is going to give us a few more graphs to go ahead and plot. We're going to substitute these graphs into our graphing calculator, and we're going to see what type of transformation happens here again. Remember, we're comparing everything into y equals x squared. One graph that we can already compare right here is y equals 5x squared. We know that when the coefficient is greater than 1, that the graph becomes more narrow. So the y equals 5x squared in comparison to y equals x squared, we know the graph is narrower. We do not know what's going to happen when we add 3 or subtract 3, and that's what we're going to investigate right now. So back over to our calculator, and I have already substituted these values in. You can pause the video and substitute in. Now that you're back, you would find out when you hit the graph button, here's what our graphs look like. This red graph is y equals x squared. That's our original function. Okay, when we multiply by 5, the green graph, notice, becomes more narrow. Now our blue graph, this is when we added 3. looks like it slid up 3 units on our y-axis. When we subtracted 7, it slid down 7 units on our y-axis. So when you add to x squared or subtract to x squared, your graph is going to translate up or down. So back over here, y equals 5x squared plus 3. When we add 3, well, the graph becomes more narrow because we multiply by 5, and it moved up 3 units. Y equals 5x squared minus 7. Again, the graph is narrow, and it moved down 7 units. Other comments that you can make here are when added to the x squared term, when you add to the x squared term, the graph translates up. And when subtracted to the x squared term, the graph translates down. Moving on to question 5 here. A few more that we're going to plug in. Remember, we're comparison into y equals x squared. Well, we can already make that comparison here. When you multiply by 5, the graph is narrow. Notice we don't have x squared. We have a set of parentheses. So we want to determine what happens when you add and subtract inside a set of parentheses. I will let you know that when you multiply by 5 on the outside, the graph becomes more narrow as stated above. I know on our graphing calculator it has not worked when we multiplied by 5. So what I want you to do on your graphing calculator is put in y equals x plus 3. Make sure you have that in the set of parentheses, and we square that. Okay, the 5 is just going to make it more narrow. So go ahead, flip over, and substitute those equations in. All right, I've substituted in my equations here. You actually can put in the 5 here, my mistake, but you need to put it in a set of parentheses. If you don't have the set of parentheses right here, it's not showing up for some reason. So we need to make sure that you have your set of parentheses and it'll graph. Remember, the 5 there is just, the graph will become more narrow. So I have my equations in there. You can go ahead and get yours in. Graph it. When we graph it, here's the original in red. Again, when we multiply by 5, that's the green graph. The graph becomes more narrow. When you add 3 inside the set of parentheses, when you're adding 3 to x, and it is getting squared, so this binomial is getting squared, the graph translates 3 units to the left. So when we add, it translates left. When you subtract, so we subtract 7 inside our parentheses, it translates to the right. In this case, it would translate 7 units. Again, the 5 is just dictating that the graph is becoming narrow. So back for our observation. Our observation is when added inside the parentheses, the graph translates to the right. Sorry, that would be the left. And this would be the right. And when you subtract inside the parentheses, it translates to the right. So our other examples, in this, the transformation that will happen is the graph becomes narrow. When we add 3 units, it will move to the left. In this case, move to the left 3 units. This graph multiplied by 5, again narrow. Subtract 7. When you subtract 7 inside the set of parentheses, it moves to the right in 7 units. Question 6, predict what the graph of y equals negative x minus 1 squared plus 6 would look like. Check your prediction here. So what do you think is going to happen? There's 3 things that you should have down that will happen. And go ahead and check your prediction. Here's my equation substituted in. Went ahead and graphed it. Here's what my graph looks like. Your prediction, what you should have stated is that with this negative sign here, your graph now curves down. We subtracted 1. When you subtract 1, you move to the right. So it moved to the right 1 unit, and then the plus 6, it moved up 6 units. That is the transformation that happened there. So again, curves down because of the negative sign, shifted right 1 unit because of the subtraction inside the parentheses, and it translated up 6 units from the addition of 6. And finally, our last question here, describe how the graph of y equals 2 parenthesis x plus 7 squared minus 4 is different from y equals x squared. Remember, y equals x squared is your basic function. That is going to curve up. It'll start from the origin. When you multiply by 2, the graph becomes more narrow. When you multiply by 2, you have x plus 7. When you add 7 inside of the parentheses, your graph will translate to the left, 7 units. Minus 4, when you subtract 4, you are going to move down 4 units. So that's what we should have stated. Basically, everything that we've worked with was in vertex form. That is your y, or function of x equals g, parenthesis x minus h squared plus k. Now, this is a great resource, a great tool that will help you out with the transformation and the translations that happen. G, notice where G is at, out inside the front of your parentheses. Well, when G is positive or negative, that'll dictate if it curves up or down. When the coefficient, or the number I should say, when the number is in place of G, if it is greater than 1 and has an absolute value that is greater than 1, the opening is more narrow. When it's between, when the absolute value is between 0 and 1, your graph gets wider. H determines if it's going to shift to the left or to the right. When you add H, you shift to the left H units. When you subtract, you move to the right H units. And then K dictates if you slide up or if you slide down. So if K is being added, you're sliding up K units, and if subtracted, you're sliding down K units. Example 1, we're going to describe the transformation caused by each component of the function. Remember, your original function is y equals x squared, so that's where it would normally curve up. So we want to know, using vertex form here, what's going to happen. Well, you have negative 1/2. This is your g value. You can look back up in the table, see what happens to g. Most of us are probably getting the concept now that when it is negative here, it's going to curve down. 1/2 is between 0 and 1, so your graph is going to become wider. The minus 2, well, is inside your parentheses. When you subtract 2 in parentheses, you're going to move to the right 2 units. And finally, your k value, which is subtract 3, when you subtract, well, you're going to move down, in this case, down 3 units. Example B. Notice your g value, nothing out there, so you can put a 1. So it's going to stay the same. Now, this 1 is indicating on what's happening on the inside of your parentheses. So when you add 1 on the inside of your parentheses, you're going to move to the left 1 unit. Negative 2 is your k value. You subtract 2, therefore you move down k units. Remember, the original function would be going through the origin. So here's the origin here. Well, you move over left 1 unit, and you move down 2 units. Here's your vertex. That's basically what you're translating is your vertex. So your whole graph translates. This concludes lesson 42.